Hi, I'm Charlie Rose, and today I'm going to share how innovative our design is here at FRC Team 1699, the RoboCats. Our team heavily focuses on key design principles when coming up with designs for a robot. We strive for simplicity, robustness, maneuverability, and consistency, among other things, in every robot we build. This year, Reefscape brought many challenges immediately apparent after seeing the game reveal. It looked complex, close-knit, fast-paced, and like it would require lots of precision from robots. This is Carl. He's our Reefscape 2025 competition robot. He has a swerve drivetrain with a pivoting elevator and is topped with an articulating wrist and grabber. He can detect coral game pieces and the reef to create automated sequences, and he can pick up from the ground and coral station. Now I'm going to talk more about my favorite part of the robot, Carl's articulating wrist. Here's a CAD model of the wrist. It's driven by two Neo 550 motors that connect on a belt from these two pulleys shown. Ignore additional or missing pulleys in some of the pictures. This design is so cool and unique because it uses a 90-degree rev gearbox, but isn't a differential system. It carries the required complexities of the task while keeping our robot simple and robust. In the left picture, the pulley that is mounted on the gearbox controls the absolute tilt of our grabber. This is useful because it doesn't have to take into account the rotation of the wrist. On the other hand, the pulley contributing to the wrist's rotation is pointed to by the arrow on the left, is on the hex shaft. This means that it relies on the tilt of our grabber, and actually when we tilt the wrist, our grabber begins to rotate. Although it may look elaborate, we greatly simplified the programming based on how we mounted the encoders, which I think is very special. The rotation encoder, mounted on the left, measures exactly how much our wrist rotates. This would be obvious if it weren't for the fact that our rotation motor doesn't directly change that encoder value. Instead, that encoder will read the change in rotation when just the tilt motor runs, forcing us to start running the rotation motor to keep it at that set angle while we tilt, such as vertical, which is very useful for scoring. Next, the tilt encoder, or more informally called a spider encoder by me, measures the exact amount we tilt our wrist relative to the fixed aluminum on our elevator. Not to brag, but I was specifically part of this, and it wouldn't have come together like this if it weren't for me. Initially, it was set out to be mounted on the hex shaft and measure how much the gearbox moved relative to that. This, in reality, doesn't give nearly as much information as the currently standing encoder. This encoder, as shown here, has a custom 3D printed interior. It has a protruding face with legs at the end of it that lock with the tilting pulley and move with it, allowing us to measure absolute tilt relative to the aluminum. Here you can see some of the first driving gameplay our team has had. Although the driving is not at match speed yet, it's easy to see just how important the wrist design is. It allows us to rapidly tilt and rotate to the coral station position exactly where we need it to be to grab coral. Next, it moves to a stowed position by rotating to vertical and tilting backwards to fit within our frame parameter, away from danger. Then it tilts forward to set up for an L4 score. Lastly, the design of our wrist has allowed us to code in a peck function which tilts down and tests whether or not we're lined up enough with the reef to score our piece. This greatly increases the success rate of our scoring and will increase the overall scoring capabilities at competition, and we haven't seen it with many other robots. One great thing that other teams don't have is a single system ground intake. We can pick up pieces and move directly to scoring them with no in-between, making us more efficient. Lastly, we really could not come up with the innovation in design that we have without constant teamwork. The designing together from kickoff that builds into a few main designs later, and then our ultimate team decision only allows us to grow after that and create consistent robots year by year, even creating new systems on a robot that we don't get to see anywhere else. Once again, I'm Charlie Rose from Team 1699, and I'll see you at our competitions URI and WPI in a few weeks.